Welcome to lesson 21. In this lesson you're going to learn about compression of image file. I am Surajmati and I'm going to guide you throughout this lesson. So by the end of this lesson you should be able to explain how images can be compressed. So just a small recap, what is compression? We have seen that compression is basically encoding information using smaller number of bits, and this will yield a file size which is smaller. And we have seen two methods of compression, lossless and lossy. In lossless compression we have seen that there is no loss of bits or bytes when the file is restored. There is no loss of quality at the same time. In lossy compression, we are seeing that when the file is restored after compression, it yields a much smaller file size compared to the original one, because there is loss of quality. We are discarding too many details. Now, when we speak of image compression, there are two techniques that you can apply to compress an image. The first one is reducing the image quality itself. Second, you can remove repetition of pixels that we have in the file. So we're going to study the first method, reducing image quality. So this is a bitmap image. As you can see, these are made up of pixels, right? So by row we have 3 pixels, by height we have another 3 pixels, row by columns you can see it, 3 here and 3 on this side. So 3 times 3, that's going to make 9 pixels. So this gives us an image resolution of 9 pixels in total. The total number of pixels make up the image resolution. We get it by multiplying the number of pixels by width and height. So as you can see, each pixel will be requiring a certain amount of bits or bytes that will be used for data storage. Now obviously reducing the number of pixels and maybe the number of bits, which is commonly known as the bit depth or the color depth, let's take it as a color depth, it will cause a reduction in file size. So obviously by reducing the number of pixels, we know that the image quality is going to be affected. Now the second method is removing repetition. So as you can see, a bitmap image itself may be made up of several pixel region, and there may be repetition in between those regions. So this one is blue, then you have red twice green, and then blue, and 3 times blue. So we can represent it using a two-dimensional representation: blue, red, red, green, green, blue for each mapping. So blue, red, red, green, green, and then blue. Now repetition can be removed. Instead of storing red, red twice, we can just say, okay, we're going to have a blue, then R2, implying that the next 2 pixels will be colored red. Green, the next 2 pixels will be colored green. Then we have 1 blue. Then B3 implies that we are going to apply, we're going to color the next 3 pixels as blue. So this is removing repetition. Now you're going to tell me which one is lossy and which one is lossless as an evaluation exercise. Do you think reducing image quality is a lossless compression or a lossy compression algorithm? Obviously it is a lossy compression algorithm, because here we're trying to reduce the number of pixels, whereas here we're speaking about lossless compression. Uncompressing this simplified representation, two-dimensional representation, will yield the same representation here, whereas this one, once you have already remove the number of pixels or reduce the number of pixels, you can't get those pixels back. Okay, so reducing image quality becomes a lossy compression, and this one becomes a lossless compression. Thanks for watching.